This is a brief demonstration of GSE Systems' desktop DesignEP. We are utilizing the Modular Accident Analysis Program, or MAP, developed by the U.S. Electric Power Research Institute, or EPRI. Many utilities use EPRI's MAP for severe accident analysis, including assessments of core damage and radiological transport. DesignEP provides an interactive, graphical way of interfacing to your plant-specific MAP model. It allows you to watch the severe accident progress and see what is actually going to happen inside the containment, the reactor vessel, and the steam generators as a result of various beyond design basis events. The demonstration plant for this scenario is a Westinghouse 4-loop PWR plant. The plant has 2 units with a spent fuel pool and a shared auxiliary building between them. The EPRI MAP program, running on the DesignEP platform, is used to model all components in both operating units and the auxiliary building. The MAP program also includes engineering safety features. This graphic shows a layout of the Unit 1 containment, reactor coolant loops, and simplified engineering safety loops, including mobile flex pumps. In the lower right corner, critical parameter values are dynamically displayed to monitor the conditions. These include pressure, water level, temperature, flex pump flow rates, and temperatures for each of our 4 steam generators. Also displayed are pressure and temperature in the upper and lower locations of the containment. In the upper right corner, there is a triangular flammability chart. This chart will display the flammability curve and the current condition in a region of interest within the containment building. With these 2 pieces of information, we may see how close the containment condition is to hydrogen combustion. It is not shown in the video, but the selected region for this chart may be changed by clicking directly on the desired location in the building diagram. The demonstration scenario is a station blackout on both reactor units, and it is initiated by clicking the SBO button near the top of the graphic. Due to the station blackout, the operating crew will be directed to the loss of all AC power emergency operating procedure and will not transition to the loss of heat sink procedure. The atmospheric relief valves for the main steam lines will not operate, and the safeties will open as the RCS heats up and steam generator pressures rise. As the steam generators steam with no main or auxiliary feed water, the steam generator levels begin to lower. After about 50 minutes, all of the steam generators in both units are almost boiled dry. The operation crew will be able to use portable generators and pumps to feed water into 2 steam generators in Unit 1 to maintain the water inventory. In this demonstration, 200 gallons per minute of water at 70 degrees Fahrenheit is fed into steam generators 1 and 3. Through this scenario, flex equipment is turned on and off to maintain steam generator 1 and 3 water level between 5 and 14 feet. Steam generators number 2 and 4 are dry throughout the scenario because no water is pumped into them. All 4 steam generators were allowed to boil dry so that side-by-side comparisons could be shown in this video. It is not shown in this video, but the power of the DesignEP platform is the ability to interact with the event. You can stop or pause the event, and you can go back in time to change parameters and watch the results. For instance, what happens if the flow rate is changed or the flex equipment is started earlier or later in the event? Data on key parameters can also be trended, saved, and exported for further analysis. What you see now is a combination of all the graphics for both Units 1 and 2. The left graphics are the Unit 1 containment and core, while the right graphics are of Unit 2. Like the containment graphic, the core graphic shows key parameter values including the reactor vessel pressure and temperature, the core water level, and the maximum fuel temperature. To illustrate the effects of mobile pump operation to provide additional cooling, no mobile flex pumps were operated on the second unit at all. We have skipped ahead to about 3 hours into the event, and the Unit 2 core is starting to melt. In approximately 1 hour, the Unit 2 core drops down to the reactor vessel lower head and causes lower head failure. As this is happening in Unit 2, the Unit 1 core has remained intact thanks to the operation crew's ability to put flex pumps into service. Unit 1 core water level has been maintained and the fuel has remained below its melting point. Here is a closer look at the flammability chart in action. You can see that the lower dome region has been selected and that the current condition is on top of the curve. This means there is imminent risk of hydrogen combustion. Here is a graphic depicting offsite accumulated dose towards the very end of the scenario. While not shown, wind speed and direction and atmospheric conditions can be included to affect distribution. The dose map is independently calculating release for both units and the auxiliary building and summing it together. Our platform can also interface with other distribution prediction programs if desired.